My name is Modric Gomo, coming from South Africa at the Institute for Groundwater Studies, University of the Free State. I will just share some perspective, of course, discussion of some emerging issues on the recent geophysical technology for groundwater exploration, with a particular emphasis on the frequency selection method. The background to this study or a presentation is that in groundwater exploration, we need to locate good sites where we can drill the bores or the wells in order to get the water or to understand other properties of the subsurface. And it's so important, and it's probably the most difficult thing, I think, among all the aspects we have in groundwater or hydrogeology. So for us to do this location of the aquifers or the places where we can drill the bores, what we need to do is we use the geophysical means on the surface to scan the ground to try and understand more about the groundwater before we can drill. Traditionally, there are two main methods that have been very common. That is the electromagnetics and electrical resistivity. These are most of the common traditional methods. But however, due to the high costs in terms of purchase, and also that because of that, sometimes this equipment is very difficult to access in many low-income regions. Of course, I will give an example of Africa, but I think also there's also other regions whereby the equipment is so much, the cost is so much. So what we have seen in recent years, I think last 5 or so years, we have seen several groundwater geophysical techniques that have emerged. And of course, the telluric electric frequency selection method is one of them. This approach, according to the information that I think has been shared by the developers that we find online or readily available, is a surface geophysical approach, meaning that we make measurements on the surface, trying to understand the subsurface. The approach uses the horizontal component of the natural electric field. There's a lot of issues that is happening now, but from the information available, it was developed in the Republic of China for groundwater exploration in the, I think, late 70s. However, from what we learn now, the equipment has only become widely available in many regions just over the last 5 years. I think in Africa, we probably have seen in the last 5 years, this equipment is now available. So because the equipment is not so expensive as compared to the traditional, the technology is also low cost of operation. It has been favorably received in many developing regions or low-income regions, but some, of course, semi-developed. I think in Asia, there's also a lot of uptake of this approach, technology, when we see. Then, however, there are some things and of course, we believe it can offer an alternative solution to the one that are existing and expensive. But there has been some issues, of course, emerging issues that are noteworthy. It's coming from, some is positive, some is negative. The first thing is that there appear to be lack of standard approaches to analyzing the data and interpreting the data, which is a challenge. So difficult sometimes to consistently apply the approach, the telluric electric frequency selection method approach. There also appears to be different schools of thought from about the principles of the method itself. We can see scholars are writing something, then we can see the equipment developers, the one that are main sources of the equipment. They also have got different perspective about how the equipment is working. So there's a bit of confusion. But however, what we also realize is that there appears to be the equipment is already widely used. I will speak from experience in Africa quite a lot, but with very limited understanding of how it works and how the information could be processed and the quality control issues. But it has been noted very good success in some cases. But of course, because of that, sometimes people are not reporting the failures. So I think just for me to continue, just allow me to do that, is that because of this background, what we're trying to do is in this presentation, we're trying to explore, of course, to understand a situation whereby how do we come to this situation whereby the equipment is widely available and used already. Different professionals, some is hydrogeologists, some is drillers, but of course there's limited scientific guidance and understanding. Of course, analysis is partially based on my own experience, of course, and literature, because I strongly believe in the approach. Then, of course, I will try to highlight some strengths and limitations that, of course, we're witnessing associated with this new technology. And at the end, I will try to recommend some aspects for future research. The emergence of the telluric electric frequency selection method, I think even the names, this equipment is popularly known, referred to as groundwater detectors. I think that has become more like a commercial name. For many groundwater professionals, as I say, this is coming in a situation whereby we have the traditional approaches and methods that has been there. So for many of the professionals, the emergence of this technology has been confronted with questions and sometimes doubts. Of course, this is because of the limited information available from the manuals. And so due to this, we realize that we're starting to ask ourselves whether it's going to be the future whereby we can have equipment already widely used but limited understanding. Or also, because of this, we end up asking questions. Of course, we want to understand how did we come up to this? We may not know exactly the exact factors that has contributed, but it's important to have a discussion among the professionals, of course. So these are some of the questions that we are going to look at. I think just to also give perspective, the reasons why maybe we have this situation whereby there's a new technology widely adapted, but still it's a mystery even how it works. And there's so many people who are using it, good success to locate groundwater, to locate water sources, but very limited understanding, of course. One of the reasons probably is that, of course, we have many standard methods that are there, but the high cost of these methods is a problem. So because of that, it leaves a gap that is always there for for equipment that is low cost, but of course and effective, So I think because of that necessity, many practitioners and drillers are willing to try something new, irrespective whether we know the pros and cons, because there's a need for such kind of innovation and technology. So I think it's one of the reasons that actually drive just the uptake, whereby people will say, look, let's try and just see how this can work, because we don't have any alternative either. But also, the other thing is in groundwater, in drilling and location of water sources, it's also easy for us to, even if we don't know more about the equipment, the technology, to test it, because you can do your survey or siting before where you want to drill your bore or a well. Then when you drill, you can compare the results to your surveys, and from there you can build the knowledge. So the higher number of studies that has shown that the equipment is quite capable. But of course, we then attribute this sudden uptake in the technology to also, it now reflects the capabilities, but of course, it also reflects the unique need that is there. Of course, there are many challenges I think that are there. I'm one of the people that I think I've started, I think, to publish case studies of this the application of this equipment, because I find it really unique and really useful. But there are some challenges that are there. I think I faced also challenges even trying to publish the work, because we have the main journals, conventional journals, and sometimes there is doubts about the principles because information is a bit sketchy. But at the end of the day, we're trying obviously to have more and more information come up. The main challenges are that while the equipment, the technology is good, there's very limited information about the technical guidance, even the principles about this approach. Sometimes we can understand that developers are also worried of the competition, so probably they are holding some aspects because they invested a lot in trying to develop this. But however, it's a problem because what it creates a vacuum, it creates speculation. So you have a situation whereby you see an equipment is very good, especially for researchers, for research and knowledge and development, but you don't know, of course, how exactly is it working? What is the principles? It can be a nightmare. But one can also argue for researchers, maybe they want more information. For contractors, for drillers, business people, they just want something that can work. Sometimes they don't care as long they can locate water, groundwater to drill the boreholes and supply the water, then a project is successful. Okay, the manuals also do not elaborate about the issue of quality control, what can go wrong when you're collecting the data and so forth. So there is, of course, some information that is there because it's smart technology. You can link it to the phone and you can create some 2D models on your phone or on your machine, on your equipment. But the thing is, the underlying principles behind this technology, the models and also the interpolation and the modeling, it's also a bit, it's not clear. So those are some of the challenges that create doubts. Of course, that also relates to the interpretation. There is no standard way that has been put forward to interpret the data. Of course, researchers are now just trying different ways, but as I say, it's easy a little bit because with experience, you can calibrate your own information. But we expect maybe there will be a better universal way that could be agreed and could be advocated to analyze this data. There's also a problem that is associated is the issue of the noise. When you are using equipment to measure, you want to understand, of course, what can go wrong. What is the noise effect? This is just an example of some of the work that we have been doing, whereby when we're looking at this data, this data is, of course, just a horizontal distance, whereby we're measuring a certain parameter, which is electrical potential difference with distance. And we can see that it looks like an anomaly that sometimes if you are looking for water, you would think there is something that is geologically useful, but we realize it's because of the noise. But then we don't have the information that can guide. When you see this data, or this on your data, it means that when you see this on your data, it also means that. And this can create, obviously, problem of misinterpretation and so forth. Positives, which I think are very good, that we can build on, is when compared to, I think, any other existing traditional approaches for groundwater exploration, this is surface geophysics. I think the telluric electric frequency selection method has got so many capabilities. It's appealing. The first one is the cost is much lower. Just to give you a quick perspective is, we will probably, for a basic equipment for the telluric electric frequency selection method, we'll probably be talking about maybe maybe not more than 1,000 US dollar, maybe somewhere there. I'm talking of the basics. Then maybe when you talk about the conventional approaches, you'll be probably talking about 10,000 or so US dollar for the, irrespective that these conventional, the traditional methods are very expensive. It doesn't also mean that they are guaranteeing. You cannot guarantee the success also. Sometimes they're even worse in terms of their results. So it's very good about that. Then the equipment, as I've said, it's smart, it's faster. You can think about maybe 20 or 30 times faster to collect the data, which also reduces the cost of projects. You know, eventually field investigation is reduced. And because of that, it's also portable, easy to handle. You don't need many people to actually help. It's also real time. When you're in the field, you can quickly instantly see your information about the subsurface geology, and you can make decisions. Very good to prioritize which area can you investigate for water, which area can you not investigate, where can you plan it. So it's actually also very good. The other very important aspect that is there with the telluric system, but as I say, this, according to the developer, is a new technology. It's not the old telluric systems that we normally were having. It's the depth capabilities. To my understanding, I think the equipment that is there now is about 4,000 meter depth in terms of exploration. And of course, this is, I've not used it. The one that I've used is about 300 meters, but literature is reported now up to 500, whereby it's verified 500 meter of prediction before drilling. And so I think it's good. The last aspect to just talk about is what we have seen is that I think there's need for professionals and scientists to promote professional discussions about obviously new technology and the limitations. Can I continue?
What type of coffee? That's cappuccino or without cappuccino? Black coffee? Black coffee.
Okay, because the fact that the scientific understanding is not so good about the approach, or is limited, it doesn't make the equipment or the approach unworthy or fake. As some examples that we see a lot online, this approach, sometimes some people are branding it as fraudulent or as fake, but actually it's led to of limited understanding. An example is that a quotation that I take here, there are several legitimate geophysical methods to look for groundwater and a number of fraudulent instruments sold as water detectors. There's no such equipment as a water detector. So if someone tries to sell you something called a water detector, you must run away quickly. What I'm trying to illustrate is, instead of people or us researchers creating a polarized world in terms of the technology, in terms of research, we must rather advocate for sharing of ideas.
Hello?
Which will help. Yes.
Hello? Yes, we have just only 3 minutes. If you
Oh.
could discuss make the discussion conclusion, please.
Okay, sure. I'm at the conclusions now.
Yeah, okay. Okay, that's fine.
Yeah, so that's the conclusion. The main important thing is that this geophysical approach, the telluric electric frequency selection method, has been favorably received in many low-income regions because of the costs, but also effectiveness, real time, and portability. And we see also many developed countries, also regions, are also starting to embrace it as new knowledge is. However, there's limited information that needs to be improved to try and get things better understanding about data analysis, better understanding about the noise effects, and of course, just to advocate that we must have health professional debate to be able to improve and promote research so that people can share the knowledge. We have seen also, even in journals, some journals are negative about the papers that are emanating from the use of this technology because of that kind of thinking that maybe it views that it is fraudulent, which doesn't help because people don't share the information, and at the end we lose valuable knowledge to understand and optimize. Thank you. This is the end of my presentation.
My name is Anca Daniela Chisoi. I work as a psychologist in a prison for women in Romania. And today I will present
Are you working in the prison?
Yes, yes, for women.
Oh. Okay.
Yes. In Romania, we have only one prison for women, and the rest are for the men. Okay, so the data that I share today are part of the first national level research aimed at identifying the specific characteristic of incarcerated women in Romania. In the early 20s, researchers first suggested that there is a link between criminal behavior and broken families. It was found that delinquents are twice as likely to come from such families compared to non-offenders. Other factors contributing to criminality include school failure or dropout, disadvantaged social environments, and poor parenting skills. The attachment theory proponents argue that offenders often develop insecure, avoidant, or disorganized attachments. Regarding to school, here, okay, studies indicate that young offenders do not attend school consistently, are considered problem students, have low academic performance, and commit crimes because they feel they have nothing to lose, as they hold low expectations for the future, display a negative attitude towards school, show indifference to academic results, frequently engage in absenteeism, and fail to follow school rules. Regarding the disadvantage...
Make the presentation show?
I'm sorry, I don't understand.
Yeah, the presentation show. Press slideshow. Slideshow.
Yes.
Your upper line of your presentation. Slideshow. Up there. Go up again. Up
okay.
Again.
This?
Up again. Up.
This is the first slide here.
Yes, but I need you to make the slideshow. Slideshow and the of the two file, home, insert, slideshow, up again, up. Slideshow.
Up.
Yes, go right.
Ah,
then
here.
Up, yes,
okay.
Slideshow, and then present it. Go right, yes. And from the current slide, go left. Yes, yes. Present.
Here.
Double click.
Ah, okay.
Yeah.
Thank you.
And you can use the space to move.
Okay. So I was talking right now about the disadvantaged social environment. Researchers find that the percentage of violent crimes is higher in areas with very low economic levels or in the most disadvantaged economic situations. The share of violent criminal acts is greater in rural areas where crimes tend to be viewed more tolerantly. Improper living conditions, low social status, family environments marked by instability and conflict, and delinquent peers contribute to the development of criminal behavior. So, considering all these theoretical approaches, I set to investigate the social context of incarcerated women in Romania. The sample consisted of 200 women incarcerated in a Romanian prison. So as I said earlier, in Romania, there is only one prison designated exclusively for female inmates. And the sample was structured into equal groups of inmates convicted for murder, theft, drug-related offenses, and economic crimes. These are the instruments that we used. The PMSC web computer is a platform developed and used exclusively by penitentiary system employees in Romania. And we found that 66% of inmates come from urban areas, 59 experienced child abuse, including physical punishment, verbal violence, and sexual abuse. Most inmates have a low level of education, with highest schooling level found among those convicted of economic crimes. 53% have no prior criminal record, and a significant percentage lack professional qualification and were unemployed at the time of arrest. If we compare these findings with existing studies, we see that the link between criminal behavior and poor parental practices is confirmed, even in Romania. The influence of early environments on individual development and the risk of criminal behavior may vary, but it's clear that a significant portion of inmates in this study have a history of abuse. Thus, the early environment plays a crucial role in the development of criminal tendencies. In the introduction, I emphasize the importance of education in child development, echoing criminologists who also highlight its role in preventing antisocial behavior. Our findings support this, showing low education level among women who engage in criminal behavior. Therefore, proper education can contribute to developing pro-social behavior and reducing criminal tendencies. A lack of education diminishes opportunities for developing practical skills and knowledge, which limits employment prospects and leads to financial problems. As our data shows, a significant portion of the inmates lacked both professional qualification and stable employment at the time of the arrest. So why is this research important? For me, the answer is simple. Identifying the risk factors of criminality is essential for reducing crime and developing a prevention strategy adapted to real social conditions. Thank you very much.
Thank you.